Imagine having a personal robot helper at home, one that can walk, carry things, and even dance. Tesla's humanoid robot Optimus is a bold step toward that vision. In recent videos, Tesla showed several Optimus units dancing in sync on a stage. An image captures Optimus bots moving fluidly to music. These demonstrations highlight what the robot can do already and hint at its future potential. Tesla's engineers describe it as a bipedal, humanoid robot capable of performing tasks that are unsafe, repetitive, or boring. Optimus Gen 3 robots performing a choreographed dance at a Tesla event. These demos show the new bots moving arms, torsos, and legs in sync. What Optimus Gen 3 can do. Although still in its early stages, Optimus Gen 3 has shown a surprising range of capabilities in Tesla's demos. For block sorting and yoga. In 2023, Tesla revealed Gen 2 robots that could sort colored blocks and even hold yoga-like poses. This proved the bots can manipulate objects and balance. Regarding event demonstrations. At Tesla's We Robot event, Optimus robots served mock drinks, played rock, paper, scissors, and danced in unison with their arms and torsos. These feats show it can grasp and hand over items and move rhythmically. For autonomous navigation, equipped with cameras and AI, specifically Tesla Vision, Optimus can navigate on its own. For example, Tesla showed a video of Optimus walking around a factory floor and finding its charging port by itself. This means the bot can recognize its environment and perform tasks without remote control. Concerning dynamic tasks, with its upgraded 22 degree of freedom hand, Optimus even catches thrown objects. A recent video shows the robot catching tennis balls mid-air with its new dexterous hand. Its previous hand had only 11 degrees of freedom. This level of fine control, such as catching moving balls, requires fast vision and motion planning. These real demos indicate that Optimus Gen 3 can walk steadily, use both hands to grasp, coordinate limb movements, and react to its surroundings. While it isn't yet performing complex home chores, it can already do basic manipulation, balance, and interaction. Such demonstrations give a tangible glimpse of what it can do today. The technology behind it. Optimus Gen 3 is essentially a bipedal machine built with electric motors, batteries, sensors, and AI, much like a walking computer. Some key technical details are as follows. Regarding battery and power, Optimus carries a 2.3 kilowatt-hour lithium-ion battery pack, similar to a large car battery. This is enough to power the robot for roughly a day of light work. When idle, it uses about 100 watts and about 500 watts while walking. In total, it weighs around 72 kilograms, which is about 160 pounds, and this includes the battery. The robot has 40 electric actuators, or motors, distributed through its body, 12 in each arm, 12 in each leg, plus neck and torso joints. These motors move the hips, knees, shoulders, elbows, and other parts. Each hand is highly articulated. The production Gen 3 version has 22 degrees of freedom in a hand, up from 11 in early prototypes. In other words, each finger and wrist has many moving joints, allowing complex grasps. There are also tactile sensors at the fingertips, so Optimus can feel when it touches something. This fine control lets it handle objects gently. For example, its precise hand could even crack an egg without breaking it. For sensing, specifically vision and proximity, Optimus sees the world using cameras, essentially Tesla's own vision system from its cars. In fact, Tesla is using the same neural net vision system that its autopilot or full self-driving cars use. The cameras feed into AI software that recognizes objects and people. For example, Tesla showed Optimus recognizing an electrical outlet and plugging in to recharge. There are no lasers or LiDAR, just cameras and computer vision. Because Tesla updates its neural network with massive driving video data, the robot's vision is improving all the time. Optimus may also have inertial sensors, like balance gyros, in its feet and body to help it balance. Regarding computing and AI, the brain of Optimus is based on neural networks and supercomputing. Tesla uses its custom FSD computer chips and a supercomputer project called Dojo to train the AI. In fact, Tesla says it has built huge video foundation models on Dojo that will serve as the brain of both its cars and Optimus. During training, billions of hours of driving and robot video teach these neural nets how to predict and plan movements. An Optimus bot runs a version of Tesla's full self-driving software, treating the world like an autonomous car on two legs. In practice, Optimus's software processes camera images to identify objects such as chairs, tools, and people, and then controls the joints accordingly. The robot is connected via Wi-Fi and cellular LTE. This means Tesla can push software updates remotely, monitor the bots, or even take teleoperation control if needed. In early demos, some prototypes were partly teleoperated for safety. Over time, Tesla plans for Optimus to run more and more onboard autonomy. In short, Optimus combines hardware such as motors, batteries, and sensors with Tesla's AI software, which is trained on Dojo and powered by FSD computer chips to function. Much of the tech is borrowed from Tesla's cars, the Vision AI, processing chips, and even manufacturing know-how. The actuators and body are custom, but the intelligence is the same kind used in autopilot. This synergy is what gives Optimus an edge in understanding its surroundings. Potential dangers and risks. Putting humanoid robots in homes and workplaces raises new questions. Experts note several possible risks. First, privacy and security. Optimus has cameras and microphones to watch your home. Security researchers warn this could be abused. For example, a household robot could collect detailed video, audio, and even floor plans of your private spaces. If the robot's network is compromised, hackers might gain access to that data. Worse, a hacker could take control of the robot itself. One security analysis explicitly warns that a hacked household robot may physically harm the inhabitants of the house. Imagine a thief controlling your household robot or using it to spy on you. Since the robot connects over Wi-Fi and LTE, weak credentials or software bugs could be exploited. Tesla will need very strong cybersecurity to prevent any breaches. Second, job and economic impact. Optimus is designed to automate low-skill tasks, which many worry could displace human workers. Musk himself notes Optimus aims to do low-skill, repetitive jobs. This is the same dull, dirty, or dangerous work often done by people today. In factories or services, robots could reduce the need for human labor. Some studies estimate millions of manufacturing and service jobs could be affected by automation in coming years. While Tesla calls this an age of abundance, others caution about the transition. Unemployment or inequality may rise if society isn't prepared. For example, if robots replace warehouse or retail jobs, what jobs will those workers have? Though not yet a crisis, it is a risk on the horizon that experts debate. Third, physical safety. Optimus is a heavy, moving robot. Mechanical or software glitches could cause accidents. If its balance fails or joints malfunction, it might fall or drop something. In the worst-case scenario, a compromised robot could even be dangerous. A security report warns that a hacked robot could be used to hurt people. In normal operation, safety systems like collision detection should prevent harm, but it will require rigorous testing. Even on Tesla's side, prototypes are often tethered or supervised. In a home, one will need emergency stop measures and clear safety standards before trusting Optimus around children or pets. Fourth, social and ethical concerns. Humans naturally react emotionally to lifelike robots. Robotics researchers note an uncanny valley effect. If Optimus looks and moves almost like a person but not perfectly, people may feel uncomfortable. For example, one analysis points out if a robot can't mimic subtle facial or body cues correctly, it can come off as positively creepy. There are also ethical questions. How intimate a role should robots play? Can people form attachments or rely too much on them? And who is responsible if Optimus makes a mistake, like breaking something or misinterpreting a command? These human factors don't have easy technical fixes and will need rules and guidelines. Tesla and regulators will need to address issues of privacy, liability, and how we treat humanoid robots. Fifth, access and inequality. Finally, there's a broader risk of unequal access. Initially, Optimus will be expensive and limited in number. Wealthy companies or homeowners may get them first, potentially widening gaps. For instance, jobs in wealthier factories might get automated, leaving poorer workers behind. Over time, Tesla hopes costs will fall dramatically. Musk predicts a $20,000 robot at high volume. But until then, these high-tech robots could deepen inequalities. Society must consider how to share the benefits of automation. In summary, privacy, security, and safety are major concerns. Economically, the shift could be disruptive without planning. And socially, living with humanoids raises new questions we have only just begun to ask. These risks don't make Optimus impossible, but they do mean Tesla and users must proceed carefully. Future scenarios and closing thoughts. What might Optimus Gen 3 lead to down the road? Experts and Musk offer some visions. As an everyday helper, Musk envisions a future where everyone has a personal robot, like C-3PO or R2-D2 in Star Wars. In that world, Optimus bots could do household chores, shopping tasks, or elder care. The idea is that robots take over mundane work, giving humans more free time. In the near term, many expect Optimus to appear in industrial and commercial settings. Tesla itself says Optimus would first handle repetitive tasks in factories or warehouses. For example, lifting, sorting, and simple assembly, with humans overseeing. Likewise, we might see robots in stores, hotels, or hospitals doing routine tasks such as carrying objects, cleaning, or guiding visitors. One analysis notes that humanoids are commonly envisaged for exactly those dull, dangerous, or tedious jobs. Over a decade or two, Optimus units could become as common in workplaces as forklifts or delivery robots. 4. Space exploration. In a more futuristic scenario, Musk has talked about sending Optimus to Mars. In fact, SpaceX plans to launch a Starship to Mars by the end of 2026 carrying a Tesla Optimus robot. The idea is that robots could help build Martian habitats or perform dangerous tasks ahead of humans. This is an extreme example, but it shows how Tesla sees Optimus as part of its long-term plans, even beyond Earth. Tesla claims Optimus could eventually reshape economies by making goods and services much cheaper. Musk has even floated mind-blowing figures, like $10 to $25 trillion in potential economic value from these robots. The optimistic vision is an age of abundance where basic goods are extremely affordable thanks to robot labor. If that happens, humanity could experience new prosperity. Of course, this is a subject of debate among economists and technologists. And a technical reality check. It's important to balance excitement with realism. Roboticists note that walking and manipulating like a human is incredibly hard. Humans took millions of years to evolve our agility and senses. As one expert write-up points out, robots still struggle with varied terrain, the fragility of objects, and adaptation to the messy real world. For example, rain, dust, clutter, or human unpredictability pose big challenges, and giving the robot human form raises expectations. If Optimus doesn't recognize subtle social cues, people may find it unsettling. In short, the tech has a long way to go. Only time will tell how Optimus Gen 3 will shape our lives. Today we see a robot that can walk, hold objects, and even dance. Thanks to Tesla's advanced AI and hardware, Tesla's vision is bold. to mass-produce thousands of Optimus robots by 2026, and eventually billions more at low cost. If even some of that succeeds, the world could change. But experts urge caution, noting the many hurdles and risks.